Okay, well I hope everybody can hear me. I'm here today to take a quick walk through Arista products and cloud network design. A different approach has been taken with Arista. I'll start with an overview of the company. Founded in 2008, or exited stealth mode in 2008. Mainly with a focus on data center networking, high performance computing and 10 gig Ethernet. A recent addition to the product line has been a 1 gig switch. We'll come to that a little bit later, but the focus is high performance 10 gig Ethernet. Currently has about 100 employees and over 250 customers worldwide. And the focus is on the architectural shift to cloud networking as legacy designs are no longer capable of dealing with the modern day requirements of the networks. The leadership is, the company is Jayshree Lal. As the president and CEO, she's come from the background of Cisco. Annie Becklestein, as you may all know, that founded Sun Microsystems, and also Granite, and Dave Cheriton, a partner of Annie Beckleστein's in many business enterprises. The products we'll look at to start off with is the first out of the gate. These products were released over a year ago, featuring SFP-based 10 gigabit Ethernet switches. Pure SFP, pure 10 gigabit. They are capable of 1 gigabit through SFP modules with RJ45 and optics, but the focus is 10 gigabit. Later on, at the end of last year, added some RJ45 T-based switches. This gives full 20 ports or 40 ports of RJ45 10 gig Ethernet that allows data centers to utilize existing infrastructure and maintain the investment on the cabling. The distances are over Cat5e, about 35 to 50 meters. With Cat6 and Cat6a, you get the full Ethernet specification of 100 meters. The latest product to ship, which is the beginning of this year, as I mentioned, is a 1 gigabit switch, which is designed for aggregation in data centers of 1 gig into your 10 gig spine. This is a 1 gig RJ45 based switch with very, very deep port buffers, which operates on a virtual output queue architecture. The previous 10 gig switches that I've mentioned all operate on a non-blocking wire speed cut-through architecture, offering incredibly low latency. New addition due to be released before the end of Q1 is the VOS. This is a virtual switch which integrates with VMware's vSphere infrastructure, allowing familiar CLI control of the virtual distributed switches in VMware. And the latest guest at the party is a new modular chassis-based switch, which I can go into briefly at the end of the presentation. Common across the entire platform, regardless of the hardware or the lack of hardware in the case of the virtual switch, is a common software image across the whole platform, extensible operating system, Arista's EOS. So we'll look briefly at each of the switches and their main features and how they go to build the new cloud architecture. 24 port switch offers the lowest latency, 600 nanoseconds, non-blocking wire speed on all ports, about 480 gigabits per second through that switch, in a 1U form factor offering layers 2, 3 and 4. 48 port switch gives you higher throughput, but as a penalty due to the number of ASICs, the traffic we have to navigate, the latency increases to 900 nanoseconds, still incredibly low. This offers the 48 10 gig ports in a 1U form factor to optimize data center space. The SX gives nearly a terabit per second throughput, and again slightly higher latency. That switch is more oversubscribed to a level of 6 to 1. the 48S is 2 to 1. The T switches share exactly the same architecture as their SFP-based brothers, however the latency does increase due to the RJ45 PHY used in the design of the hardware. So quick look, close up, the pretty unexciting, I'm sure we've all seen switches before, but showing very clean architecture, architectural design, SFP ports and management ports, USB for storing software images and software upgrades, and a console port for conventional serial access.
Excuse me, can you go back to the previous slide?
I can.
We have one of those, the 7124S here, and during the break you can have a look at it physically in front of the auditorium. Thank you.
Forgot to mention that bit, sorry. Okay. The RJ45 switches, slightly different looking, but they offer 20 ports of RJ45 and 4 SFP for your 10 gig uplinks, and 40 ports and 8 ports. The same management features on there. The 7000 series offers a full 48 ports of 1 gig connectivity with 16 meg port buffers, 768 shared across the switch, but very deep port buffers. Wire rate layer 2 and 3 switching, and as I mentioned earlier, offers virtual output queue, store and forward architecture rather than non-blocking cut through that the 10 gig switches offer. On the right there, the actual hardware inside the switch is pretty much identical, and from the back across the whole product line, all the same hardware architecture, offering full 5 hot swappable fans. A lot of other vendors will offer redundant fans, but some you do actually have to power the switch down to change your fans in the event of an outage. Hot swappable power supplies, of course, common across most offerings. How to plug it all together? Well, we've got an option of 10 gig SFP for your opticals, standard short range, long range, plus short range light, which offers low power consumption, and long range multi-mode as well. The most efficient way of connecting within the data center is the twin-ax cable. Without the use of optics, this offers very, very low power consumption, or negligible power consumption, because there's no optic module to be powered. And within rack, when you've got a rack full of servers, the cables can go between 5 meters, 7 at the most, but offers a very economic cost for building your racks out. RJ45 as well for maintaining the existing infrastructure, and for connectivity for legacy equipment, 1 gig over copper. The 1 gig copper into the 10 gig switch is only 1 gig on the RJ45. The plug-in module doesn't do 10 gig. The only way to get 10 gig on RJ45 is using the T-based switches. Okay, well, the core of the Arista platform is the extensible operating system, quite unique in the market for the features that we'll cover going forward. The platform itself is based on a Linux core at its foundation. On top of that sits the Arista EOS. It's a completely all processes run in the user space, so they're completely protected, and this offers a very robust and scalable, extensible operating system. You've got stateful fault containment and stateful fault repair. Also in-service software updates. So if you need to patch a switch due to any errors, then this can be done while the switch is still running. So you have the switch hardware, Fedora core kernel. On top of that sits EOS and all the major modules that make up layer 2, layer 3 switching, OSPF, SPIT spanning tree, link aggregation, and the real grunt work at the bottom, such as NEDs and simple hardware drivers such as yourself. So For a link down, that will notify the ASIC driver. The sysdb then informs the LED drivers to turn the LED off. Simple as that. So, software fault containment and stateful fault repair. So the ASICs are happily forwarding their packets along, and if an agent experiences a fault, then the sysdb, the process manager, will exit and start a new instance. All this time, the ASIC and the switch itself continues to forward the packets without being affected. The agent loads its new state from the sysdb and continues without any interruption to the data path. And the system resumes normal operation. In-service software upgrade follows the same principle. The defective agent with a bug might be running. The administrator can deploy the patch and the agent is killed, much the same as software fault containment. And the process manager detects the exit, starts the new instance with the new code, and your bug is fixed. So, extensibility, because the whole system runs on the Linux kernel, it allows a great deal of extensibility by the user themselves, in as much as you can add new agents, new extensions. For example, if you're running a data center and you want your servers pixie booting, rather than having a dedicated server, the pixie boot server can now sit at the top of the rack, along with the DHCP server, for example, within the switch itself. It's blurring the lines between servers and the network. Network extensions, as I'll go into a little bit later, the 1 gig 7048 switch has Arista partnered with Citrix, and the 7048 switch actually features a built-in Citrix NetScaler to provide layer 4 to 7 load balancing for Citrix infrastructures. On top of that, you can install Nagios agents, for example, third-party management, and this allows you to have local Nagios agents that relay back to your main Nagios installation, as an example. So, use cases that have been seen so far, as I mentioned, the layer 4 to 7 cloud load balancing, that's referring to Citrix, Pixie boot servers, DHCP for top of rack deployments, and Nagios as a key management addition to the extensions. So, as I mentioned, EOS allows user level access to Linux on a switch, which is quite unique. Simply type in bash at your CLI and you drop straight into the Linux shell. It's useful for simple tools, uptime and memory checking, and going on from that you can do some deep spanning tree debugging in the Linux level itself, the Linux kernel itself. As I mentioned, adding extensions, this is just an example of adding fping to the switch. It's done, the adding of extensions, even though they're RPMs, is still done at a standard, industry standard CLI with conft. So you can add your extensions there, or you can actually go into Linux itself and add the extensions using RPM.